Hello everybody, this is Dr. Nurbat Shah. Today's video is about operations defined on functions, and obviously we'll be talking about graphing of functions which are translated or which are scaled. So the main operations defined on functions are summation of functions, sum of two functions, difference of two functions, product of two functions. We also talk about quotients of two functions. That means how do we add two functions, or how do we find subtraction of two functions, how do we multiply two functions, or how do we divide two functions. Okay, so the sum and difference and product of the function is usually defined as if you have two functions f and g, right? So in that case the sum will be defined as simply f plus g. That's the notation used for sum of two functions, and that is equal to what? It's a simple algebraic sum of those functions, right? For example, if we have one function that is defined as x squared plus 2, whereas the other function is g, which is defined as x minus 3. So if you want to find f plus g of x, that would be simply f plus g. We take sum of these two functions, x plus 2 plus x plus 3, which would give you x squared plus x plus 5. That's simply the sum of these two functions. Similarly, if you want to take difference of these functions, it's algebraic difference of the functions f of x and g of x. If you consider the same example, so in this case f minus g will be x square plus 2 minus x plus 3. So in this case you would say x square minus x and plus 2 minus 3, that would give you minus 1. So the difference of these two functions will be x square minus x minus 1. And if you talk about the product of these two functions, so f into g is the notation used for the product function, and then we have what? We simply algebraically multiply the two given functions. Like in this specific example, if you want to find f of f into g of x, so that will be the product of these two functions, x square plus 2 into x plus 3. You can simplify this to get another function. So that is basically defining the product of these two functions. But the question is, what would happen to the domain of these two functions if we have domain of f. If domain of f is represented by df, domain of g that is denoted by dg, let's suppose, then domain of their sum or their difference or their product, that would be simply the intersection of their domains, right? Whereas in case of product of the function, the same concept will be used. You simply need to take intersection of these two domains of f and g. Whereas in case of range, obviously we cannot define a general rule for it. Range is always tricky. You have to use different methods when we have a different type of function based on their domains. Right, so that's what these functions f plus g, f minus g, and f into g will be defined for all x belongs to their intersection df intersection dg. That would be the domain of f plus g, f minus g, and f multiplied by g. Whereas the quotient is only defined when g of x is not equal to 0, and because if g of x is 0, obviously this function will not be defined. Well, if you talk about domain of f divided by g, if g is not as a whole 0, so that is also df intersection dg, but we will exclude those points where g of x is 0, excluding those points where g is 0 because they will not be included in the domain. Okay, there's another operation as well in functions that is known as composition of functions. So in composition of functions, what do we do? You see, generally जो हमारे पास functions होते हैं, they are defined on a variable, independent variable x, and for output variable f of x. लेकिन समटाइम्स इट हैपन्स कि यहाँ पे हमारे पास जो इस फंक्शन f का इनपुट होता है वो एक और फंक्शन होता है. इट कुड बी एक्स स्क्वायर, it could be x plus 1, it could be x square minus x plus 2, and that could be under root of this one. So whenever the input of a function is another function, that becomes a composite function. Like f of x is equal to x square plus 1 under root. It's a composite function, which is already a composition of two functions. One function will be under root x, whereas the other function will be simply g of x, that is x square plus 1. So this is known as a composite function, and the process of getting this function from two given functions is known as composition of functions. Now, how do we find this composition of functions? First step, you need to understand what is the notation used for it. We usually use this notation f of g of x, which is defined as f of g of x. For two given functions, if we have one function y is equal to f of x, whereas the other function y is equal to g of x. Then we define composition of these two functions is the domain of the input of this function should be the output of this function. Similarly, we may find g of f as well. So g of f is equal to g of f of x, where in this case domain of this function is the input of this function. For example, if we have two functions, y is equal to f of x is equal to, let's suppose that is under root x, whereas y is equal to g of x, another function that is, let's suppose, x square plus 3x minus 1. If you want to find f of g of x, or we call it f of g of x, so that basically means we need to replace everything in this function x by this quantity. That would give you what? That would give you x square plus 3x minus 1. And if you want to find g of f of x, that basically means g of f of x. So in this case, we first replace this f of x with under root x, and then putting x, replacing x by under root x everywhere in this function, g of x. So we will be having under root x squared plus 3 times under root x, and then we have minus 1, which could be simplified as x plus 3 under root x minus 1. So that's a composite function, which is a composition of these two functions, under root x and this function x squared plus 3x minus 1. So keeping in mind that domain of f in this case will be the range of g, whereas in case of g of f of x, domain of g will be the range of f of x. Let's do some example. You see, if f of x is equal to under root x and g of x is given as x plus 1, and if you want to find f of g of x, so that basically means we need to find f of g of x. That basically f of x is defined as x under root, so we'll just replace x under root with g of x to get under root g of x, and then replacing g of x with x plus 1, it is given here. So that is what? X plus 1 under root. And then look into the nature of the function, you can simply find its domain and range as well. Whereas if you want to find g of f of x, so that case we'll simply write it is g of f of x, and then replacing x everywhere in function g of x by f of x, we get f of x plus 1, and then replacing f of x with under root x. And so on. We can simply find f o f of x, that means f of x, and g o g of x, that means g of g of x. That means inside g, replace x with a function again. Okay, next we talk about graphing of functions which are either shifted or which are either scaled. If we know graph of a function y is equal to, let's suppose, x square. What would happen if we simply shift the function or transform the function with the transformation x plus 3 whole square? What would happen if we do same thing in the other direction, x minus 3 whole square? What would happen if we have a function like that, y is equal to x square plus 3, or we can write that as y minus 3 is equal to x square, that is subtracting 3 from y. We can write y plus 3 is equal to x square. What would happen to this function? So this is the example. These are the examples basically of translation of function, and this is defining the direction. If you are adding or subtracting a number with x, it means we are translating or transforming shifting the graph along or the function along x-axis. If you are adding or subtracting a number with y, so in that case we are shifting the graph along y-axis. It could be upward, it could be downward. So if we know graph of a function y is equal to f of x, what would happen if we add a number with this function f of x plus k, where we say k is a positive number, or we can say subtracting a number k from this one. So what would happen if we know the graph of y is equal to f of x, right? So this graph will be shifted k units upward. If we are subtracting a number from y, or we are adding a number with the function like this one, so in this case the graph of function y is equal to f of x, that will be shifted accordingly k units upward if we have added a number to a function or subtracting a number from y. We are the same thing if we are subtracting a number from it, f of x minus k, or we say y plus k, that is equal to f of x. In that case, the function f of x graph will be shifted k units downward. The shape of the function will be exactly the same, the only difference will be in the position, in the origin. We do same thing in case of horizontal shifting as well. If we have a graph of a function y is equal to f of x, and we want to find graph of y is equal to f of x plus k, where k is a positive number, in that case we will be shifting the graph k units to the left. Whereas in case of y is equal to f of x minus k, again with k is positive, we will be shifting the graph of y is equal to f of x k units to the right. Let me explain this with an example. Let's suppose we have a graph of y is equal to x square. Then if the graph is shifted to the new position, you see 2, but this will be a graph of y is equal to x minus 2 square. Where if the graph is shifted to the new position on the left side, in this case the function will be defined as y is equal to x plus 3 whole square, and vice versa. If you know the graph of y is equal to x square and you want to draw the graph of y is equal to x plus 3 whole square, that basically means that you need to shift the graph 3 units to the left. Whereas in case of graph of y is equal to x minus 2 square, the graph will be shifted 2 units to the right. Similarly, if you know the graph of y is equal to x square, this is the graph of y is equal to x square, and if the graph is shifted 2 units upward, so the graph equation for this function will be y is equal to x square plus 2, or we say y minus 2 is equal to x square. because you see the graph is shifted 2 units upward, and vice versa. If you know the graph of y is equal to x square, if this is the graph of y is equal to x square and we want to find graph of y is equal to x square plus 2 or y minus 2 is equal to x square, so you would shift the graph 2 units upward. You see that it's a 1 unit and then 2 units. Whereas in case of shifting graph downward, it will become its graph basically 1 unit downward. So function for this graph will be y is equal to x minus 1 or y plus 1 is equal to x square. This will be a graph of y is equal to x square minus 1. We can also do scaling and reflection of function graph. If you know the graph of y is equal to f of x, and we want to find, for example, we are given graph, we know graph of y is equal to under root x. What would happen if I take 1 over c, any constant, dividing with y or multiplying the same quantity with function y is equal to c into under root x? हम इसको इस फॉर्म में इसलिए लिखते हैं क्योंकि जो कंसेप्ट हम यूज़ कर रहे हैं वो सब सेम हो जाएगा। यानी अगर हम y को डिवाइड कर रहे हैं किसी भी पॉजिटिव नंबर के साथ, नंबर ग्रेटर देन 1 के साथ, तो उस केस में जो ग्राफ होगा y इज इक्वल टू एफ ऑफ एक्स का, दैट विल बी स्ट्रेच्ड। तो इफ़ यू डिवाइड y by a constant, so there will be stretching in y direction, stretching like that. You'll be stretching the graph like that. And if you multiply y with some number, in that case we'll be simply compressing the graph in y direction. And if you repeat or you do same process with x, like if you multiply x with a constant, so in that case you will be doing compression in x direction. And if you divide x, so you will be doing stretching in y direction. Just for sake of simplicity हम क्या कर रहे हैं कि अगर आपने y के साथ एक नंबर को डिवाइड किया तो आपने y डायरेक्शन में स्ट्रेचिंग करना है। अगर आपने y के साथ किसी नंबर को मल्टीप्लाई कर दिया तो उस केस में आपने y डायरेक्शन में कंप्रेशन करनी है। अगर सेम यही चीज़ हम x के साथ कर देते हैं, यानी अगर आपने x के साथ डिवीजन कर दी है तो उस केस में x के डायरेक्शन में स्ट्रेचिंग होगी। अगर x के साथ मल्टीप्लाई किया हुआ है तो उस केस में कंप्रेशन x डायरेक्शन में होगी। अगर हमारे पास फंक्शन का ग्राफ पता है, इफ़ यू नो ग्राफ ऑफ ए फंक्शन y इज इक्वल टू फंक्शन f ऑफ x, यहाँ पे कोई ग्राफ है। If this is graph of y is equal to f of x and we want to find graph of y is equal to minus f of x, in that case you have to reflect the graph about x-axis. It means the graph will become like that. And if you want to find the graph of y is equal to f of minus x, in that case we'll be doing reflection about y-axis. If the graph is somewhere here, reflect about this one, so it become like that. So that is something called reflection of a graph, and these are known as stretching and compression of graph, जो कि usually scaling के केस में आ जाता है. This is an example. You see the graph of y is equal to under root x. This is the graph of y is equal to under root x. If you want to find graph of y is equal to 1 by 3 under root x, तो you see that basically यहाँ पे 3 मल्टीप्लाई हुआ है, तो जब हम मल्टीप्लिकेशन करते हैं y के साथ तो वो क्या होता है, y डायरेक्शन में कंप्रेशन होती है। तो हमें इस ग्राफ को डाउनवर्ड कंप्रेस करना है y डायरेक्शन में। यूँ असल में यहाँ पे ब्रांच नहीं है तो इसलिए इस तरफ से तो कोई कंप्रेशन नहीं होगी, तो इधर से हम कंप्रेशन करेंगे और वो यहाँ पे आ जाएगा। बाई अ फैक्टर ऑफ व्हाट, बाई अ फैक्टर ऑफ ऑब्वियसली वही, अगर सपोज करें हम 1 पे देख लें तो 1 पे इसकी वैल्यू स्क्वायर रूट की 1 है, लेकिन जब हम 1 by 3 करेंगे तो इसकी वैल्यू 1 by 3 पे आ जाएगी। Similarly, if you divide this with 3, something like that, 1 by 3 into y, so we are doing what? We are doing stretching. So you will be stretching this graph accordingly 3 units upwards. Like you see जहाँ पे function की वैल्यू 1 था अब क्या हो जाएगा, अब वही वैल्यू उस पॉइंट पे 3 हो जाएगी. We do same thing with in x direction as well. If this is the graph of y is equal to under root x, if you are given graph of y is under root x, and if you want to find multiplication with x, तो जब multiplication होगी तो उस केस में इसी ग्राफ की क्या होगी, compression होगी. In case of multiplication we do compression, whereas in case of division with x we will be doing stretching, लेकिन डायरेक्शन अब सिर्फ चेंज हो जाएगा, x डायरेक्शन में होगा. Okay, next is talk about reflection. See, if this is the graph of y is equal to under root x, then graph of y is equal to minus under root x will be simply reflection about x-axis, whereas graph of y is equal to under root minus x, that will be reflection about y-axis. So we can basically draw these graphs without constructing or making tables and then plotting the points and joining those points to straight lines or whatever the curves. आपको ये सब करने की ज़रूरत नहीं होगी. इस केस में हम डायरेक्टली क्या करेंगे, इस केस में हम डायरेक्टली ओरिजिनल जो ग्राफ हैं, फंडामेंटल फंक्शंस के जो ग्राफ हैं, उनको अकॉर्डिंगली या तो रिफ्लेक्शन होगी या अबाउट एक्स एक्सिस या अबाउट वाई एक्सिस, या इसमें स्ट्रेचिंग या कंप्रेशन होगी, या इसमें फिर shifting होगी along x direction or y direction. So you can simply draw a graph of different type of functions. I'll just practice some of them in exercise. Okay, so let's talk about exercises in Thomas book. That's exercise number 1.2. In question 1 and 2 and obviously 3 and 4, some functions are given and they are asking about domain and range of their sum and product. So in the first question they say what would be domain of f and what would be domain of g, and then their sum and product. So see, domain of f in this case, that will be all real numbers, because we are having simply a function is x, which is a polynomial, and domain of polynomial is always a set of real numbers. Whereas the second function is under root x minus 1, so we will be talking about domain in this case, that all real numbers greater than or equal to 1, because otherwise नेगेटिव हो जाएगा और वहाँ पे पीरियड डिफाइन नहीं होगा. सो यहाँ पे जो हमारे पास डोमेन आता है, दैट इज 1 to infinity. That's the domain of f, and this is the domain of g. Now what about domain of f plus g? That would be, as I said earlier, it will be the intersection of domain of f and domain of g. That is all real numbers intersection with the 1 to infinity. You must know that ये सेट इसका सबसेट होता है, तो इनकी इंटरसेक्शन से क्या आएगा, ये वाला 1 to infinity आ जाएगा. Whereas in this case अगर हम देखेंगे तो इस फंक्शन का जो डोमेन है, यह आ जाता है हमारे पास x plus 1 should be greater than or equal to 0. That means x must be greater than or equal to minus 1. So we have one domain to be minus 1 to infinity. Whereas for this function we will be taking x minus 1 is greater than or equal to 0. That means x will be greater than or equal to 1. So in this case this is domain of f, whereas domain of g will become what? That would become from 1 to infinity. Now domain of f plus g, or f multiplied by g, in this case that would become what? Domain of f intersection domain of g. Domain of f intersection domain of g. So domain of f is what? That is from minus 1 to infinity, whereas domain of g is 1 to infinity. Now in this case 1 to infinity is basically what? That is the subset of minus 1 to infinity. So this domain will become what? This domain of this function will become 1 to infinity, and that holds for both function, for f plus g and f multiplied by g as well. We can do same thing for question 3 and 4. They are asking about domain and range of these functions. Okay, so if we talk about question number 1, in this case domain of f is all real number because it's just a constant function. So domain of f is all real numbers, whereas range of f in this case will be only 2 because it's a constant function, and the range of constant function is just a number, whatever the number is. Whereas domain of g for the second function, that will be again all real numbers because it's a x square plus 1. Whereas a range of this function will be real numbers starting from 1 and going to infinity, which can be simply found as taking y is equal to x square plus 1, then we take x square is equal to y minus 1, then we have x is equal to under root y minus 1, and we take the square root is defined with y will be greater than or equal to 1. So range of this function is what? Range of g, that will be 1 to infinity. Now what about domain of f by g? So you see x square plus 1 is never 0, so domain of f divided by g or g divided by f both will be, that will be all real numbers because we have to take intersection of them. So r intersection r, that will be simply r, and there is no point where these two functions are 0. So a domain of f divided by g and g divided by f will be what? That would be all real numbers. Now to find the range of this function, the range is always tricky, we need to find range. So for that purpose, if you define f of g of x, so that basically means f of x divided by g of x, that means 2 divided by x square plus 1. Now how define range of this function? For that purpose we first find the range of x square plus 1. We know that x square plus 1 is always greater than or equal to 1. So 1 over x square plus 1 will be less than or equal to 1. We have a rule that if a is less than or equal to b, and then 1 over a will be greater than 1 over b, provided a and b both have same sign. The same thing here, you see x square plus 1 is greater than or equal to 1 all the time. So 1 over x square plus 1 will be less than or equal to 1. But we want to find a range of this one, so it means 2 divided by x square plus 1 will be less than or equal to 2 always. But the point is that this function can never give you a negative value, right? So it means we cannot take this value to be 0 or negative. So its value is less than or equal to 2, but that will reach up to what? Range of f by g, that would be simply starting from 0, excluding 0 because it can never be 0 as well, 0 and going up to 2. If you don't see that, range in this case will be 0, excluding 0 and going up to 2. Its value can never be greater than 2. In similar way, we can find a range of g by f as well, that is x square plus 1 divided by 2. Now you know range of x square plus 1 was found earlier, that was starting from 1 and going to infinity, but now we are dividing that by 2 as well, so this range becomes 1 by 2 to infinity. And similarly we can do the same thing in question number 4 as well, because domain of this function is 1 is all real numbers. Domain of this is what? That is starting from 0 and going to infinity. So domain of their sum, their product, their quotient will be same as this one. And similarly we can find its range as well. This is question number 5 and 6, which are given in exercise 1.2 of Thomas book. So in this case, you see we are given f of x is x plus 5, g of x is x square minus 3. These are very simple question. You would first find g of 0. So g of 0, that means putting x equal to 0 here in this function. So 0 square minus 3, that would give you minus 3. And then we find f of g of 0. That means f of minus 3 because g of 0 is minus 3, and then putting minus 3 in this function. So we have minus 3 plus 5, which is equal to 2. So the value of this function will be 2. Similarly, g of f of 0, it can be found in similar way. We know f of 0 in this case that will be 0 plus 5, that is equal to 5, and then g of f of 0, that means g of 5. Now putting x equal to 5 in the second function, that is 5 square minus 3. It's 25 minus 3, which is 22. So g of f of 0 is 22. You may pause the video and practice some of the questions from both 5 and 6. It's a very simple question, so you can do that. Right, in these questions, we are given function for one graph. You see, this is for this one, the function is given as y is equal to minus x square, and then the graph is shifted to two new positions, position B and position A. So at position A, you see the graph is shifted 7 units to the left. So in that case, the function will become what? It will become minus and then x plus 7 whole square, because the graph is shifted 7 units to the left. Similarly, this graph is shifted 4 units to the right, so it will simply take y is equal to this is y is equal to minus x minus 4 whole square. This is the graph, a function of this graph. Okay. Similarly, we can do the same thing for question 24. I hope you can do that. Just pause the video, and because in this case the graph is shifted 5 units downward and 3 units upward. So just try to do this question. In 25, what do we do? In this case, we are given functions and corresponding graphs. So we have to map them, we have to match them. Okay, so in the first one is what? It is y is equal to x minus 1 whole square minus 4. So x minus 1 whole square is showing that the graph is shifted 1 unit to the right, minus 4, that means 4 units downward. So a graph in among these, position 1, 2, 3, 4, a graph which is shifted 1 unit down to the right, this one, you see, this is 1 unit shifted to the right and then 4 units downwards. It means the first one is position number 4. In this case, 2 units to the right and 2 units up. So this one is 2 units to the right and 2 units upward. So this is position number 1. Then 2 units to the left, 2 units up. So this one, 2 units left and 2 units up. So that is position number 3, and this will become obviously position number 4. Similar case for this one as well. In this case, we are given graphs and a function y is equal to minus x square. So we need to find graph for the other positions as well. So for position A, I am doing one position for you, and then you can do the rest as well. Y is equal to minus x square is the original function, whereas you see this is the graph which is shifted 1 unit to the right and 4 units upward. So the function will become y is equal to minus x minus 1 square plus 4. 1 unit to the right and 4 units upward. So 4 units upward means plus 4, and 1 unit to the right, that means x minus 1 whole square, and so on. It's the same thing for B. That will become y is equal to x plus 2 whole square with minus sign obviously in the front, and then plus 3, and so on. You can do the rest as well. So these are some questions. I'll just do some of them. Like x square plus y square is equal to 49. This is simply a function which is defining a circle. So graph of the original function will be like that, equation will be like that. Centered at origin and radius is what? That is 7. Now this is shifted 3 units down and 2 units to the right. So what about the equation of the new one? When we shift this 3 units downward, so in that case what do? We add this number to y, and left we will be adding this number to x. So it means x plus 2 square y plus 3 whole square is equal to 49. And what about the graph? In this case, the graph is shifted 3 units downward and 2 units to the left, so it will somewhere here. So we will be drawing a circle with a radius 7 and center at this position now. Similarly, if you see this one, if I do this question number 30, it is shifted 1 unit to the right and 1 unit down. So it will simply take y is equal to x to the right, so minus 1 square, and 1 unit down, so it's minus 1. And the graph can be drawn easily. Similarly, y is equal to under root x, that is shifted 0.81 to the left. Right, so if this is shifted to the left, so what would happen? Y is equal to under root x minus 0.81. Keeping in mind the domain will be changed, and so on. You can do all of them. If you see question number 37, it's a graph this function. So we are given y is equal to under root x plus 4. So the corresponding original function, you could see that will be y is equal to under root x. Now we draw first the graph of y is equal to under root x. This is the graph of under root x, and then it is shifted 4 units to the left. So we have 1, 2, 3, 4, and then we draw the graph like that. This will be the graph of y is equal to under root x plus 4, because it is shifted 4 units to the right. This is graph of y is equal to under root x. Similarly, in 38, we need to write this function first, like we will take minus common from it. So it's minus x minus 9. So the original function in this case will be y is equal to minus under root x. Okay, and graph of y is equal to under root minus x is something like that. And then it is shifted 9 units to the right. So let me take that. Let's suppose this is 3, this is 6, this is 9. So we'll just draw a graph from here like that. Similarly, absolute x minus 2 graph in question 39. We know graph of y is equal to x absolute is known, so that's the graph of y is equal to x absolute. And then we shifted the graph 2 units to the right, so it's 1 and 2, so the graph will be like that. The classic Inca. If you talk about this graph 42, y is equal to 1 minus under root x. So you know graph of minus under root x is this one, and then we are subtracting it from 1. That means it is basically same as minus under root x plus 1. So it will be shifted 1 unit upward. The graph will be shifted 1 unit upward. So this is 1, so the graph like that. Using those shifting and along x direction or y direction, we have to use all these concepts to draw the graph of these functions. Okay, in question 57, we are given a graph of a function and corresponding domain, and then we have to draw the graph and domain and range of these functions. So domain of the original function is what? That is 0 to 1, that's the range, and domain is what? That is from 0 to 2. Now the first one is domain of f of x plus 2. F of x plus 2, that basically means we have to shift the graph 2 units upward. So you see this is 1, this is 2, may draw a line like that, and then you will draw exactly the same shape what we have there. This is 1. So it is 1, this is 2, this will be 3. Domain will remain the same from 0 to 2. The only thing is change in range, and that's the graph of new function. So in this case, domain will remain same. That would be from 0 to 2, whereas range will be starting from 2 and going to 3 now, because we have shifted the graph 2 units upward. Whereas f of x is equal to -1, so in this case what would it do? We would simply shift the graph 1 unit downward. So if this is the graph, so we just bring it 1 units downward, so the graph will become here, something like that. Okay, so you see in this case domain will remain same from 0 to 2, whereas the range will become what? That will start from -1 and going up to 0. So in this case domain will be 0 to 2, whereas range will be starting from minus and going up to 0. 2 times f of x, it will remain the same graph, but only we have to stretch that upward, stretching up to 2. So domain will remain the same, whereas range will become what? That will become 0 to 2 now instead of 0 to 1. Minus f of x is basically the reflection about y is equal to x, y is equal to 0, मतलब x एक्सिस पे हमने इसको रिफ्लेक्ट करना है, तो बाकी वही रहेगा. Domain will remain same 0 to 2. The only difference will be in range, and that will become -1 to 0. f of x plus 2, in this case the graph will be shifted 2 units to the right. It means the graph will start from 2, to the left, not to the right. So the graph will starting here like that. So domain will become -2 to 0. Range will remain the same. Whereas f of x minus 1, in this case the graph will be shifted 1 unit to the right, so it start from here. So domain will become 1 to 3, whereas range will be same as 0 to 1, and so on. F of minus x is a reflection about y is equal to about y axis, so it will same graph, just only difference is it will become the other side. So domain will be -2 to 0, whereas range will remain same, that one. And then we have f of minus f of x plus 1 plus 1. That means you have to shift the graph of minus f of x, which is this one, 1 unit to the right and then 1 unit upward. So somewhere graph like that. So in this case domain will be -2 to 0, whereas -1 to 1, and the range will be from 0 to 1 as well. You may do the same thing for the next exam question. Just may pause the video and draw the graph for it. So thank you very much for being with me for a while. If you have any questions, any queries, any confusion, just drop question in the comment box. I'll get back to you. Thank you very much, and please subscribe to my channel just to get notification once the new video is being uploaded. Thank you very much. See you in next video.